Welcome to June 11th LeetCode Challenge, Stone Game 7. Alice and Bob take turn playing a game where Alice goes first. There are n stones arranged in a row. On each player's turn, they can remove either the leftmost stone or the rightmost stone from the row and receive points equal to the sum of remaining stones values in the row. The winner is the one with the higher score when there are no stones left to remove. Bob found he was always losing the game. Poor Bob. He decides to minimize the score difference. Alice's goal is to maximize score difference in the score. Given an array of integer stones, where stones at index I represents the value of the ith stone from the left, return the difference in Alice and Bob's score if they both play optimally. So there's some key things to take away. There's a lot of good bolded words here, so they each remove a stone. The ith stone is from the left side. And if they both play optimally, that means that Bob wants to minimize the score difference, while the goal of Alice is to maximize the score difference. So this approach is so once again we see that we have an end result, and we want to make decisions based on that, going from a previous step. So it's a classic dynamic program question, and that's how we're going to approach it. And let's take a look at this example here. We have an array of stones, given like that, and then the output is 6. So the explanation is that, for instance, if Alice goes first, she takes 2 from the right-hand side, and the remaining number of stones is the sum is equal to 15 points. Hence, Alice has 15, Bob has 0, and the new array is stones with 2 removed on the right-hand side. Next, Bob removes a 5 from the left-hand side. The remaining stones equal to 8. Now Alice has 13 points, and Bob has 8 points, and the new stones array looks like this, because we have 2 and 5 removed on both sides so far. Next, Alice removes a 3 from the left-hand side, and the remaining points are 5. 5 plus 13 from the previous point she had equals 18, and Bob still has 8, and the new array is 1 and 4 left. And then we see that Bob removes 1 on the right-hand side of this array here, and there's removes a 1, I should say, on the left-hand side, and there's 4 points left remaining. 4 plus 8 equals 12, so Bob has 12 points, while Alice has 18 points. And the last stone is 4. Once Alice removes the 4, there's 0 points left, so there's nothing added. So totaling 8 Alice with 18 points, Bob with 12 points, the stones are empty, and then we return the difference between Alice's and Bob's score, which is 6. So at the end of the day, if we go through the first, let's copy this and kind of go through it. So we have this. We see Alice removes from the left-hand side. So we have Alice has 13 points. So we have 13 points. We can actually minus it from each step. So every time after Bob draws a stone, we can minus it from that. So we have 8. Right? This is for the first round. And for the second round, Alice will have a total sum of 5 points, while Bob has a total of 4 points. So we can do this: 5 minus 4. So each step of the way, we could do something like this. So we could break down the question to look similar to this. So instead of minusing it at the end, or summing the total of each of the points at the end, we could sum it at each step after each time Bob takes a point. If we do the math on this, it equals to 6. However, we could also rearrange this in a way that looks a little bit more like a nested type statement. So we could do something like this. It would be 13 minus 8 minus 5 minus 4. So it looks something like this. So we could do it kind of like looking like a nested statement. And from that is pretty much how we're going to approach this type of problem using a dynamic programming array. So at the end of the day, we want to be able to take the maximum. So we want to take, for instance, dp of I and ending at j. This is the element on the right hand side that we're going to take. You want to take the max of the basically the max of what we had in on one side, or the alternate route. So this is how we're gonna kind of approach this question here. So let's start off with define the length of our list. So n equals length of stones, and then we're gonna define an array of an array. So we're gonna go with let's see, we want to start with for 0 for, we could say n, we could say start, we could say j. Let's go for and no, that's right there, for right in range n. So we're making two loops here for left in range n. We want to define an array that has 0, and for each element n, let's say total equals 0. Okay. We want to iterate through each stone. For a stone in stones, what we want to do is calculate the total. Of the stones, and then we append that to our array. All right, now we have our pre-calculated route. Now we're gonna basically, this is the meat of our function here. So for each element in the range, so we can't go through 1 because 1's already appended, right? It's already index 0. We want to start at 2, so it's 2 all the way to n plus 1. What we want to do that is run for each left element in the range of n plus 1 minus our element, but our next at the range. What we're gonna do is we're gonna update our right value to left plus element minus 1 because of the one before it. We want to reassign our dynamic program for left, right values. So we want to take the max of our array at the right plus 1 minus our array at the left plus 1 minus our total that we have. So in our dynamic programming double array. So we want left plus 1 times the right. Alright, we also want to take the max between, let's say, array n. Let's do it for the other side now. Minus array left. Oh, what am I doing? This is right. Minus our dynamic program double array from the left side to the right side. Right there. So that should potentially work. And at the end of this, we want to return our dynamic array at index 0 to n minus 1. Equals there for right, left, right, left, right, left. Let's see if this works. So yeah, 6, 6 is what we get to expected. Accepted. So this is time complexity is big O of n squared. So if the constraints are small enough to do a big N O squared problem. We also know that this is using a dynamic program approach. However, I think we could actually remove one of the arrays. So let's go for a little bit faster. So for spacing complexities, it's I would say is a big O of n. We're using an array within an array. We're keeping track, so big O of n squared as well. However, can we make this a little better? A little better. The answer is let's try it. Let's try it. So instead of finding a total array, an array, and a double, let's just change it to let's combine these two together actually. So we're gonna do an array of 0 star n, and then what we want to do is instead of using left and right, let's see. I'm just gonna redefine these two elements, combine them together. So let's say for the for the left of our element in reverse in the range. So we're gonna start from the backwards now, which it would be kind of fun to see if it works. Score is we're gonna update our. We're gonna have SF total. I'm just gonna use score this time. What do you mean total still works? Actually, let's go score. We're gonna have score the stones. So stones at element left, and we're gonna have also a total variable here, initialized to 0. So I'm gonna erase. We're gonna do something similar to this, but a little bit different. So for right in range of left plus 1 to n, what we're going to have is we're going to have our maximum total equal to total. So we're going to rewrite what we did before, but a little bit better. Total stones at right. And we're going to do our demo. We're going to use our right dynamic program right. We're going to do the same thing, max of our max total minus our dpn, dp at the right side, or the total plus the score minus our dynamic program at the right side minus 1. And what we want to do is update total to our max total. And for here, you want to just return the last element of our dynamic programming array. Let's see if this works. Let's see. Accepted. Yeah, that's a little bit better. So this one, let's see, space complexity and time complexity is still big O of n squared because we do have a nested for loop here. However, space complexity is a little bit easier because we do have this big O of n, but it's only using one array size. Well then, this one's a lot shorter. It's probably a bit easier to read actually than compared to the first one. But yeah, there you go. Have a nice day.